Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Quit la Huac by AQJHS. And here are the rules. Normal Sudoku rules apply in the 9 by 9 grid, which means that we fill the entire 9 by 9 grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a 3 by 3 box. We also have the digits on columns and rows read in both directions, make a total of 36 9-digit numbers. So, for example, this is one 9-digit number reading from left to right, but we also have a 9-digit number reading from right to left. And so this is typical rank. I think this is rank rule set, where basically every column and every row read in both directions is a nine digit number, right? And we have a total of 36 of them. The numbers in the pills outside the grid, read left to right or top to bottom, show the rank in ascending order among those 36 numbers for the indicated columns or rows. Show the rank in ascending order among those 36 numbers for the indicated column or row in the direction of the clue. There are no ties in rank, and pills can contain any digit from 0 to 9. So basically, yeah, you'll have the digits, you'll have the numbers 0, 1, all the way up to 36. And the tens digits are always on the outside. Actually, no, that's not true. They're always on the left or the top digit of a pill. And the ones digit will always be on the right or the bottom side of a pill. So if, for example, this was 22 and 1, that would mean this 9-digit number here, amongst all the 9-digit numbers that we have in the grid, must be the 21st in ascending order. So the lowest is basically the first in ascending order. The second lowest is the second in ascending order, etc., etc. So the 21st would be above 20 other numbers, 9-digit numbers, and it would be below 15 other, it'd be above 20 other of the 9-digit numbers, and it would be below 15 of the other 9-digit numbers. So whatever number you had going this way would be the 21st smallest number. Spaces marked with circles, so these circles contain odd digits, and spaces marked with squares contain even digits. So those are odd and even. Any 3 adjacent spaces along a teal line must contain digits in different residue classes, it's remainder classes essentially, modulo 3. That is 1 each of the set 147, 258, and 0369. So those are essentially the digits that are from 1, 4, and 7. If you divide by 3, you get a remainder of 1. So that's why those are the 1 modulo 3 class. If you take 2, 5, and 8, divide by 3, you get a remainder of 2. So those are the 2 modulo 3 class set, essentially. And then if you take 0, 3, 6, and 9, divide by 3, you get remainder of 0. So that's a 0 modulo 3 set. So for any 3 spaces along a modulo line, you'll have to have 1 from each of those sets. And then the final rule is digits joined by a teal dot belong to the same remainder class modulo 3. Residue, yeah, I guess my guess is it's just a translation thing. That is to the same set from 147, 258, and 0369. So so these digits, for example, here, they are of the same remainder class. So if this were, say, a 1, this would have to be a 1, a 4, or a 7 here. Because these have to be any two digits separated by one of these teal dots are in the same remainder set, which would be 1 modulo 3, 2 modulo 3, or 0 modulo 3. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. These are all... So all of these digits are odd. If they are in the first... In the leftmost column, they are 1 and 3. If so that's all. If they're topmost column, they're 1 and 3 also. So this is 1 or 3, and this is 1 or 3. We also have squares. If they're in the topmost, they are 0 or 2 here. So this is 0, 2, 0, 2, 0, or 2. These are in different modulo sets. So since these are different modulo sets, one of them's 0, the other one's 2. So one's 0 modulo 3, the other one's 2 modulo 3. Therefore, this must be 1, 4, or 7 modulo 3. And we'll color that red. These are different modulo sets. But we don't know which ones these are. These are all odd. But they're also all different modulo sets. One of them has to be 2, 5, and 8. So one of these is a 5, but we're not sure which. The other one has to be 3, 7, or 9, but we're not sure which. So 5, and then 3, 7, or 9 here. These can be any from 0, 2, 4, 6, or 8. Same here. These are all the same modulo set. These are the same modulo set. These are the same modulo set. All of these digits, though, are 0 through 3. All of these digits are 0 through 3. This is 0 through 3. These are all 0 through 3. And this is 0 through 3. 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 Okay. Where do we start here? These are going to be 3 different ones. These are 3 different ones. Therefore, this must be 3 different ones also. Okay. Anything with 1 on the grid to start with is likely to have a 0 at the beginning, right? It's not guaranteed, though. Okay, so this is the same set as this. If you have 0, how likely is that to be 3? It's not that likely. Right, so this can... Oh, wait, this could be 1 also. Right. That's not helpful. Wait, if this is 1. Hold up. Okay. Right. That's one thing I forgot. So 1, anything that starts with a 1, there's going to be 4 9-cell numbers that are going to start with a 1. Then there's 4 9-digit numbers that start with a 1. 4 9-digit numbers that start with a 2. 4 9-digit numbers that start with a 3, etc., etc. So the ranks of 1 through 4 all start with a 1. So 0, 1, 0, 2, 0, 3, and 0, 4 all start with 1. 0, 5 through 0, 8 start with 2. 0, 9 through 0, 12, sorry, 0, 12, 0, 9 through 12 start with 3, etc., etc., right? So if this were 1, this could never be 0, and it could never be 20, right? 1 starts with 0, so that actually does work. 1 would be 0, 1, 0, 2, 0, 3, 0, 4. 4, what is 4? 4 goes from 13 to 16, right? It's basically everything, the number divided by the number multiplied by 4, and then the four numbers that include that one and then are below it, are directly below it. So 1 times 4 is 4, so you have 1 through 4. 2 times 4 is 8, so you have 5 through 8, etc., etc. So for 4, it would be 16, 13 to 16. So this could never be 4. It's 1 or 7 here. And the 7 would have to be, for 7, it would be times 4, so it would be 28. 25 through 28. So that works. What about these? The same sets. So if we try to have 1 here, that would be with 4, right? It must cross, essentially, whatever the digit here must cross the these have to be different sets, essentially. This is the same set as this, but it must be different than this. This has to be, though, the same set as that. So whatever this number is must essentially be like, it must be like 19 and it must be like 17 to 20, or like 9 to 12, or something along those lines. So what are the digits that possible there then for that case? So you have 9 to 12, which would be 3 in that case here. This is also, so I think this is, no, not quite the same. This is actually the same sum, so that's fine. These are different, but these could be same or different, we're not sure. This is different from both of these. That's interesting. Oh, wait, no, but that's not the tens digit. That's the ones digit. Okay, that's not helpful. So these are going to be very important. Particularly this one is very important, I think. So we start on this one. So the ones that change here, right, are 9 to 12, which is 3. So that would be 3, this is 0, and this is 1. Okay, so let's look at that. So 0, this would be 0, this would be 1. So then this would have to be 0, 9, because these are the same set. So that does actually work there. This is 1 and... oh, this would have to be the same set, which doesn't work, right? This is the same set as that. Same modulo set. But this would have to be like 13, or... it can't be 12 because it has to be 0 modulo 3. Oh, it could be 10. So this, no, that actually does work. So this could be 3, 0, 9, 1, 0 here, because this is the same modulo set as this. What's the other ones? It's from, if you go 1 to 2, that would be 20. So I think that's 5, right? If you have 5, this would be the same modulo set. It would have to be 20, but that 2 and 0 are not the same modulo set. So that doesn't work for 5. Right? It would have to be 5 with 20. And that would be the only two possible in the tens digit. And that doesn't work. And then the final one is up to 32. So that would be 8. So you have 8, and then you have 20. That doesn't work either, right? Because if you have 28, that would be 7 times 4. So that doesn't work either to be in the same set. So this has to be 3 then. So this is 3, this is 09, that's 3 in the corner. We celebrate because we get our first number, and this is 10. So this has to be 2, 5, or 8 here. That's different than this. It could be 5 if this is 20. That's fine. It could be 8 if this is 28 or 29. That's also fine. So we have one of each set here. So this is 9, which means reading this way, it must be smaller. It's likely to, but we don't know. This then has to be greater than... It has to be at least 2 or greater. We don't know which, though. 3 cannot be any of these. If this is 7, this has to be 2, and this is 0, which would force this to be 2. If this is 1, this is 0. This would have to be 2, so this would be 5 or 8. So both of those work. What else do we have? Okay. If this is 1... Oh, okay, there's a certain amount for these 1-3s, right? To start with 1, it has to be either 3, 4, or 5. So it's 3, 4, 5 here. To start with 3, it's either 8 or 9, I think, right? 3, 4, 5, 8, 9. 0 or 2 is similar, actually, I think. So it's 3, 4, 5, 8, 9. This is 3, 4, 5, 8, 9. This can never be 1. It's 3, 5, cannot be 7. So this is 3, 5, 9. This is the same set. So this is 3, 4, 5, 8, 9. And it must be the same set as this. So it's 1 modulo 3 or 0 modulo 3. So it cannot be 5 or 8. This is 3, 4, and 9 here. Wait, can't be 3. If these are all the same, 3 can only be with 1 at the start, and that's not the same modulo set. So this can't be 3. So it's either 1 with 4 or 3 with 9. So 1 with 4 means it could be 13 through 16, right? So that would mean it's 14 here. If it's 3 through 9, it's 33 or 36. We're not sure which. Because those are all 0 modulo 3. What about this? Okay, so this is also 3, 4, 5. Oh, well, okay. We have all the 3, 4. We have a 3, 4, 5, 8, 9 quintuplet in column 1, which eliminates 3, 4, 5, 8, and 9 in the rest of the column. Therefore, these must be 1, 2, 6, and 7. Now, they can never have 3 they can't actually have 1 either, right? As the tens digit. 1 and 2 are from 0, 1 to 0, 8. And so these are all 0, 2 here. Interesting. 6 and 7. 6 can be 21 through 24, and 7's 25 through 28. Interesting. Okay, and then 2 of them are different sets than the remainder that they're here, right? That doesn't tell us much. This cannot be 3. What does that tell us? Okay. Here is also 3, 4, 5, 8, and 9 as possibilities. This is 0, so that's 3. These are 0 and 2. So that would be 0 and 2 can be 1, 2, and 3, right? Because it can go 0, 1 to 0, 9, and 3 is included there. 4 cannot be. 5 could be. So it's 5, 6, 7, 8. So 1, 2, 3, 5, 6, 7, 8. So that's much less restricted. Or not much less, but less restricted there. What else? Huh. This is the same set as this. So if this is 0, it can only be 3 here, except that we don't have a 0, 9 possible anymore. So it cannot be 3 there anyways. So this can never be 0. Okay, that's important to know. Right, we already have the 9th smallest 9-digit number. We also have the 10th, actually, also. So 3 is not going to be very common. 1 requires essentially a 1 modulo 3 here. That could be 4 then. 2 requires a 2 modulo 3, so that's 5 or 8. Either of those work. And then 3 requires a 3 modulo, sorry, yeah, 0 modulo 3, which would be just 9. 6 is only 20, 21 through 24. So it's 4, 8, 5, 8, and 9. Which matches this. This one has to be different than that. So 0 could be with 1 or 2 here. 1 could be with, I think this is pretty broad. Yeah, I don't think it's helpful. This one might be helpful. Oh, these are different sets than... Right, these are different sets than the ones that they have here. Okay, so for 0, this is the same set. This can't be 3, though. That's interesting. Okay. So for different sets, actually for the same set, this can never be 3. Oh, it could... Yes, it can never be 3, because we already have a 3, 0. Well, it can't be 3 anyways. I don't think this can ever be 0, right? If this is 0, it forces that to be a 3, but we already have a 3 there, so this can't be 0. If it's 1, The same set could be 4. It cannot be 7, though. If it's 2, it could be 5 or 8, because 8 can be 29 through 32. So this is similar to this one, right? With the same set. And 3 can be 9 here. Okay. Oh, these are all the same set too, and it can't be 3, so 0 can never be here. And I think these are the same, right? 4, 5, 8, and 9. Right? 1 can match a 4 starter, which is 13 through 17. Right. Okay, so one thing for this, if this is 0, it could be 1 or 2. That fits. If it's 2, it cannot be 5 or 8 here. Right? Because that would be the same set. Oh, actually, that's the same here. If this is 0, it could be 1 or 2. That works, because those are different modulo sets. 2 cannot be with 5 or 8, because those are the same modulo set. So we have a 1, 2, 6, 7, interestingly enough. This can't be 0 again, because 3 can't be here, so this can't be 0. It's 1, 2, or 3. If it's 1, it has to be 4. So this is very similar here as the 4, 5, 8, and 9 thing, right? Because, yeah, these are the same. If it's 4, this has to be, both of these are the same modulo, so it has to be 14. Because those are all 1 modulo 3. If it's 5, it would have to be 20, but that's not possible, so this can't be 5. If it's 8, it would have to be 28, which can't be, that's 7. So that's for the number starting with 7. So it cannot be 8 and 2 here. Then 9 could be 33 or 36. So this is also, this is the same as this, essentially. This can't be 0 for the same reasoning. It could be 4, 5, 8, and 9 here, because these are the same set. This cannot be 0, because if this were 0, it would have to be 1, 2, or 3 as a start digit, which it's not. It's 4, 5, 8, 9. So it's 1, 2, or 3 here. These are different, right? So 0 matches with 1 or 2. That's fine. 1 could be 3, no 4. It could be 5. 5 and 1 here, which works. 6 works with 2. 7 works with 2 also. 8 works with 3. And 9 could not work. That's interesting. There's got to be something with these, right? One is obviously different from 0. 2 is obviously different from 0. We already have a 3 in the column, so we don't need to worry about that. 4 is not different from 1. But that doesn't matter, because we already have 4s available here. Oh yeah, this is definitely bigger than that. Because this is, well, not definitely. I mean, we know it's definitely bigger, but it looks also bigger as possibilities, right? This can never be 0, because it starts with the 4. So 4 cannot be any of these. 5 could be any of these because it could be 1 something, right? 6 works also here with a 2. 7 works with a 2. 8 works if this is 3. And 9 does not work here. Right? Because 9 has to be with a 30 something in the ranks. Hmm. These don't have to be different, actually. I was thinking that one has to be 1 and the other one has to be 3, but that's just normal Sudoku thinking. Oh, we have a 3, 4, 5, 8, 9 triplet, or quintuplet, not triplet, quintuplet in row 1 also, which makes this 1, 2, 6, and 7. Interesting. What does that tell us? I'm not sure. I don't know what that tells us. Wait, this can't be 4. If this is 4, that forces this to be 1, and there would be the same set along the modular line. So this cannot be 4. It could be 5 if this is 1. Okay, so 3 matches with 1 only if it's 2 here, right? Because we can't have 11, we can't have 10, because that would match this. So 1, 2 if this is 3. If this is 5, you have 17 through 19. And the only one that's... So 1 is 1 modulo 3. The 8 is 2 modulo 3, which we already have. So it'd have to be 19 if that's the case. If it's 8 modulo 3... Oh, that's interesting. Right, so... If we have 3, this is 12. This has to be 11. That could work, actually. That does work. Possibility. So 1, 2, 3, 1. So that does work if that's 3. If it's 5, this has to be 19. And this must be 17. So far we have 3. This is 12. This is 11. If we have 5 here, this is 19, and this is 17, because it has to match that. If it's 8, we have 30-something. It would have to be 1 modulo 3, so this is 31, and this would be 30. So that does work that way. So that'd be 30 that way. It cannot be 29. So 29 through 32, the only one... Oh, it could be 29. Actually, it could be 29. That does work. That, too. Okay, well, that's too bad. If it's 9... Cannot be 33. Could be 34 or 35. Oh, wait, it can't be 9. Right. Okay, so those are the possibilities then. It's 3, 5, and 8. 9 always has a 30-something, so this cannot be the same set as this. If this was a 3, this would have to be 1. But the problem is this can't be 2 because it's odd. So this can never be 3. Okay. What if it's 5? These are all different sets, remember. If it's 5. Okay, so if it's 5, that means it's 1 something. And 5 can be 17 or 19. The only ones that are different, so 5 can be 17 through 19 with the 1 start. It would have to be 19 here then. If this is 9 here, this is 3, and that never works. Okay, so we know then what this is. This is 5. This has to be 1 and 9, right? 9 can never be with, this is 1 or 3. So again, we had 4, 5, 8, 9 as possibilities. 3, 4, 5, 8, 9. Actually, 3 can never be here. No, 3 can be with any ones, right? So, but the problem is we don't have 1, 2 as a possibility. So this can't be 3, 1, 2. So that's the reason why 3 can't be here. This is odd again. So this is 5. We can try 5. 5 works with 1 and 9 as the 19th ranked lowest one. 7 doesn't work because it goes with 2, and 2 is not odd. 9 only works with 3, but the problem is they have to be different sets here, and 9 and 3 are the same set. So this only makes this 5, which means this cannot be 5. Oh, that's interesting. So this can't be 5 either. 5 is one of these 3. Okay, so if this is 3, let's go back. This is 3. This has to be 12, and this is 11, and that works because we have 9 here and 10 here remaining. If this is 8, this is a 3. It requires 31 to be here. And this would be this 0 mod 3. So it could be 30 or 29. Okay. This is an even digit. So if it's 1 or 2, so say it's 1 here. That makes this 0. You could have 0, 2 or 0, 4 as the rank for 1. If it's 2 here, this is 0 also. Wait, hold up. It has to be different remainder sets. So if it's 1, this is 0, 2 specifically. Can't be 0, 4 because 4 and 1 are the same set. If this is 2, it has to be 0, 5 doesn't work, 0, 6 doesn't work, 0, 7 does work, so it's 0, 7. Oh, but that's odd, so that doesn't work. 0, 8 doesn't work. So if it's 2 and this is 0, it would have to be 0. We have 0 mod 3, 2 mod 3, so this would have to be 1 mod 3, which only could be 4 if it's even, so this can never be 2. If this is 6, wait, why do I have this? Oh. Right, because this has to be 1, 2, 6, or 7 here remaining, so this is why it's 0, 2. If it's 6, and this is 2, that means that leaves a remainder of 1. Right? 2 is 2 mod 3. 6 is 0 mod 3, so we need a 1 mod 3. And the only even one is 24. So it's either 0, 2 or it's 0, 4. If it's 7, that's 1 mod 3. 2 is 2 mod 3. So it could be 6 here. And it cannot be 3, it cannot be whatever. Okay, so we've gotten all those digits. What about this? 4 can be with 1, but it can't be because they're different modulos. Sorry, they're the same modulo set. 1 and 4 are both 1 mod 3. So this can never be 4. This is 8 or 9, which forces this to be 3. If this is 3, this can never be 9. So this is 8. And this is odd. It has to be the same, different modulo. We have 0 and 2 mod 3, so this must be 1 mod 3. which is 31 then. So this is 8, which makes this a 3. So this is 12. That's another 3 in the corner. We celebrate because we're getting closer to solving this. That makes this not 3 or 8. This 8 means this can't be 8. This can't be 8, and this can't be 8. So we have 31 for the 8. This cannot be 3 anymore, here or here. So this is either 2 or 3 here. This is the 31st rank, which means this is third. It's the third lowest, which is the second highest 8. It's unlikely to be 8, 1. And if, well, so this is 29, 30, or 32. Not helpful. This is the same set as this 1's digit. And it has to be different than this one. Okay. The 9 has to be one of these two here, because 9 cannot be either of these. 9 has to have a 3 there, and this 9 has to match that, right? So 9 cannot be there, because that 3 can't be there if it matches. If this is, that could be 9 or 3, that could be 9 or 3. So one of those is the 9. This can't be because it doesn't match this one. This one cannot match 1 or 0, so it's 2 or 5. Okay, what else do we have? If this is 1, these are all different. So this would be 0. This must be 2 mod 3, so this would be 2 specifically. But it's even, so this is not 1. Right? If this is 1, that forces this to be 0, 2, but that has to be an odd digit, so that doesn't work. If it's 2, this is 0. This has to be 1 mod 3, which is 7, as an odd. So 5 through 8, with the 2 being there, the only one that's 1 mod 3 is 7. If this is 6, this is 2, so this needs a 1 mod 3. 6 is 21 through 24, so that works with 21. Right? 21 starts with a 6, that's fine. 7 and 2, that's 1 mod 3 and 2 mod 3, so it must be 26, but that's not odd. The only other ones would be 23, which is a 6 starting number, and 29, which is a 8 starting number. So 7 does not work. This is 2 or 6 then. This works 1, 6, 7. This could be anything. So to match this, one could match 0, 1 or 0, 4. 2 can match 0, 5 or 0, 8. 6 can match 23. And 7 could match 27. So those are the possibilities there. This number is smaller than this number. So this cannot be 9, right? Because this is 11. This is the 11th largest. This is the 12th largest. So if this were 9, the problem is that this would not work, right? This would have to be 4, 5, or 8, and therefore would not be the 12th largest. So this can't be 9. This has to be 4, which makes this a 1. This can't be 4. This is 9 now, which makes this 33 or 36. We're not sure. So that's 3. This has to be greater than 4. This must be 4 or less. So this has to be 4 here, which makes this 1. And 4, the 4 must be 13 through 16. So it has to be the same set. It's 14 then, which makes this not, this is not 4. This is not 4, so 4 has to be one of these two. This is either 2 or 6. If it were 2, the problem is that that would be smaller than 3, 4, 2. And this is supposed to be bigger than that. So this has to be 6, which forces this to be 2, and this is 7 then. No, 21. Right? 6 can be 21 through 24, and 21 is the only odd digit for the ones place. So this is 21. This can't be 6 then. This can't be 6. And this can't be 6. This is 4, which is the 14th largest. This has to be less than a 6 because we have 3, 4, 6 here as the 11th. So this must be smaller. So this is 5, which means this has to be the same set. So this is 20. Right? Because 5 can only be 17 through 20. So this is 20, which makes this a 1 mod 3. So this is 1 or 7 here. This can't be 5 here. This is 1 or 7. That means this starts with 0 or 2 here. Yeah. So 3, 4, 5. So we have all the 3s. 5, 1, 7. What else do we have? 4 cannot be any, well, 4 can't be any of these anyways. This 5 means this can't be 5, so this has to be 2, which forces this to be 0, which makes that a 2. Therefore, this can't be 1 anymore. This has to be 7, because it's 1 modulo 3. This is 2, so this is 5, 6, 7, or 8 here. Do we have a 2 anywhere else? No. So this can't be 2 or 7. This can't be 2 or 7. This can't be 2 or 7. Well, we have a 1, 6 pair now in the row. So this can't be 1 or 6 here. This can't be 3, so this has to be 5 then. So this is 5, which forces this not to be 2, so this is 3, which makes this either 30 or 32. We're not sure which. This is 5, this is 3, so we need a 1 modulo, which is 1. And this is the same modulo, so it has to be 18, right? 2 mod 3, 5 only goes from 17 to 19 with a 1. This can't be 5. This becomes a 4-9 pair here. So this must be 1 or 3 here. That's fine. This is 1 or 6. That's interesting. This is 8, 5. 18. We've got all the 3s on the edges. We have 4 of the... Okay, this 5 eliminates 5 here. This becomes an 8, 9, 8, 9 pair, which eliminates 8 and 9 in the rest of the row. So this can't be 8 or 9. It's a 4, 5 pair here. This 8 or 9 can only be with 2 or 3 here, right? Same here. This is 2 or 3. These are the same sets. This can't be 4 or 5 because of that 4 and this 5. This can't be 4 or 5 because this 4 and that 5. So either one works. If it's 8, this has to be a different set. 8 goes from 20, can be 29. Actually, it has to be 29 then. So if this is 8, it's 29. So one of these is 29. Right? These are different sets. So if this is 8, here, this is 29, no matter what, because this has to match that modulo set. So it must be 2. And the only rank that 8 has in the 20s is 29. If it's 9 here, and this is 3, it has to have a different set. So it cannot be 33 or 36. So it could be 34 or 35. So either way, one of these is 20, right? That means this is 8 or 9, so it's 1 or... It has to match here, too. But if this is 8, and it matched here, and it matched here, the problem is we can only have one that matches, which is the 29th rank, right? Because 8 goes from 29, 30, 31, 32, right? 8 times 4 is 32. You take the 4 digits, including 32, 4 numbers, including 32 before that. So this can never be 29 and 29. So this has to be 30, and this is 9, with 34 or 35 here. This is 30, obviously. Something. We don't know what that is, though. This is 39, which makes this 8. This is 29 here. Therefore, this is 0 mod 3, this is 2 mod 3, this has to be 1 mod 3. So this is 1 or 7 here. If it's 1 or 7, that could only be... 1 can only be with 0, 7 can only be with 2. 3, 8, so that fits the ranking. Right, 3, 4, 6, and 3, 8 here. 2 and 6 both have to be here. That's interesting. This is a 4-5 pair. This can be many things. Okay, it's 4 or 5 here, which means this cannot be a 3. So this is 1. This is 1 too, right? 4, 5, 4, 5. So not 0 mod 3. If this is 14... Okay, what's all the possibilities? 14 can be, 14 can be from 13 through 16. And then 15, 5 something could be 17 through 19. So not 0 mod 3 is 4, 5, 7, 8. Okay. Interesting. These are the same modularities. This is 13 through 16 here. Okay, what are the possibilities again for 1 and 7? If it's 1, this is 0, so this has to be 2, because you need a 2 mod 3 there, and it's even. If it's 7, that's 25 through 28. 7 is 1 mod 3. 2 is 2 mod 3. We need a 0 mod 3. And so it has to be 6, 26. Okay. Let's try this one again. Okay, 1 can be, this is the same set. So 1 could be 0, 1 or 0, 4 there. 2 could be 0, 5 or 0, 8. 7 can be It has to be 27 if that's the case. Okay, so that only limited 1. So we got all the 3 sets. This 8, this could still be 1 here. So we don't have any. So this digit has to be less than the highest one of that. So this cannot be 9. So it's 1, 2, 1, 2, no 3, 4. Could be 5. Could be 7. Cannot be 9. Okay. Because it has to be less than. Oh, wait. This is 8, 5. So it has to be less than 5. Okay, this can't be 5. This can't be 7. So this is 1 or 2 here. That's fine. Oh, yeah, it's 1, 7. So that is the only 1 mod 3 is possible here. This is 1 or 7 here. The remaining digits here are 1, 2, 6, 7, 8. This can't be 6. This could be any of those. This has to be the same set as that. So if this is 1, this could be 01 or 04. If it's 6, this is 23. It has to be 23 in that case, right? 14 is 13 through 16. 4 something is 13 through 16. 9 something is 33 through 36. So this is 3, 4, 5, 6 no matter what. What else do we have here? This actually doesn't seem too bad, but I don't know. This can't be 14 because we already have the 14th ranked. These digits are what? 1, 3, 1, 6, 7, no, 7. 1, 6, 8, 9. That's possibilities. This is the largest 5. This is the second. So yeah, this is the largest 5. This is the second largest 5. This is the third largest 5, which means that if it's 17, it can only. Okay, so if it's 5 something, it can only be 17 here. So this can never be 8 or 9. This can never be 8. Okay, that's interesting. This is 33 through 36. This is 33 or 36. Interesting. So this could be 33, 36 still. This could be any of them. We cannot have 14. Oh, right. You can't have 414 here anymore. So this can't be 414. This has to be 9, 3, and 4, 3 or 6 here. Which means this is 4. This has to be 4, 1, no 4, obviously. The 1 modulo 3. So 4 can only be 13 through 16. The only 1's digit that has 1 modulo 3 is 14. Therefore, this is 33 and 36 ranked. This is 33, 36 ranked, which makes this not 33 and 36 ranked. This is 9. This is 4. We have 3, 5, 6, 3, 5, 6. This is the 14. One of these is 3, 4, 5, 6. We don't know which. What else do we have? Ah, this can't be 1 because this is 4, right? So these are the same modulo set. If there was 1 and 4, that makes this not 1, so this is 6, which makes this 2, right? That's 0 mod 3, 1 mod 3, 2 mod 3. This must be then 23 to match the 6. So this is 1, which forces this to be 0. That makes this 2, 5, or 8, because we need a 2 mod 3 in that line. This can be obviously 1 through 4. We have 23 here for this 6. We have 21 for that 6. We need another 6. So, well, that can be 6 because of that 6 anyways. This is a 20. This can't be 6 here. So this still could be 0, 1, 2, 3. Actually, it can't be 3 because this is 1, 2, or 7. So this can never be 3 here. This 9 is either 33 or 36. So it's either the lowest or the highest. That's very varied. 2, 5, or 8 here. Oh, this is 1 or 2. Where's the 14? I mean, technically, it could be 4, 1. It could be even 4, 2. This is the 14th. This is obviously 25 through 8, but we don't have any number with it. Okay. Ah, 1 is here, which means this can't be 1. So this is a 7, which makes this a 2. So none of these can be 7. We also know none of these could be 3 here. You can't have a 1 here for any of these either, right? 1, 2, and 6 can only be 1 and 2. Numbers that start with 1 or 2 can only be 0, 1 through 0, 8. 6 can only be 21 through 24. So this is 1 or 2 because it cannot be 6. So this must be 0. Interesting. So this is 0. This must be the same set. So this is either 3 or 6 here. Cannot be 9 because 0, 9 starts with a 3. This then can't be 0. What can it be? It could be, I guess, a lot. Still 1, 2. Okay, so these are different. That's interesting. These are the same set. So 7 can be 5 through 8, right? Okay, then we have all the 3 set. This is a 4. This is 4. 5. We don't have very many. We do have a lot of ones there, considering, but it's not on the grid. So this is 2. We have all the 3s, 4, 5, 6s, 7s, 8s. We do have an 8. And then 9s. That's a lot of 9s. So blue, Right, so it's really the corners that we're interested in. Okay, so this is 1, 2, or 6 here. Obviously, if this is 2, then this has to be 0, which means this is 1. And that's 6. This can't be 30, it can't be 0, 0. Well, it doesn't, can't, well, okay. Can't have a 0 here. You could have 1, 2, no 3, 4, 5, no 6, 7, 8, no 9. So that matches 0, 1 with 1, 0, 2 with 2, 0, 4 with 1. Sorry, 0, 1, 0, 2, and 0, 4 match with 1. 0, 5, 7, and 8 match with 2. 21, 2, and 4 all match with 6. Okay. These are different sets, right? So for ones, the 1 would be with 0. 2s would be with 0. We don't have very many limitations there. We don't have any, really. Sixes. Well, we have 23 and 21. So this, okay, well, it can't be 6 anyways, so that doesn't really help. Okay, so if this is 1, this could be 0 and 5, and that works fine. Actually, does it? Yeah, kind of. So if this is 1, this is 0, this has to be a 5 here. That would make this 34, which would be fine because 9, 1 is less than 9, 4 or 9, 5. So that works, I guess. If this is 2, this is 0, this is 34 and 35. That does not work, right? So if this is 2, this has to be 0, which would force this to be 4. So this is 34. This is supposed to be smaller than that, which is 9, 2, which is not possible. 9, 4 would always be greater than, or 9, 5 would be greater than 9, 2. So this cannot be 2. If this is 6, this would be, well, this would be bigger. So this would have to be 35. This would be then 34. So 6 and 4. The problem with 6 is that it has to be with a 2, which is the same. No. Actually, that does work. 6, 2, and 4. That does work. Because that's 35 here. So 9, 6 is greater than 9, 4, 9, 5. So that does work. So 6. Okay, so what are the possibilities here? This could be 1 with 0. 1, 0, 5 works because 9, 1 is less than 9, 4, 5. And this is 35, the 5th in rank. If it's 6, this is larger. So this is 35, this is 34, and that works with 20 something. Because 6 is 21 through 24. 7 is 25. So that does not work. If 7 were here, this has to be 25 or something like that. Sorry, this would be 2, 20 something. But then the 4 and the 5 would be 1 mod 3 or 2 mod 3. And 2 and 7 both cover that. So 7 cannot work here. 8 can be... So 8 is 2 mod 3, which forces this to be 34 and 35. So that does work. So that forces this to be 30 something, which it does work because we have 29, 31, and 1 of 30 or 32. So those work too. Okay. Hmm. This is yellow here. uh, okay. So we've got all the 3 set. The 4s we're not really close to. Oh, wait. Okay, this... So this 4, if it were 9, the problem is this 4 would be less than it, and this 4 would be less than it, right? So this can never be 9. If it's 8, then you have the same problem, right? 4, 8, we know this is less, and this is less, because it would have to be 2 or 5 here. So this can't be 8. It could be 6 here, and this is 8. That could work. So this is 1 or 6 here. Hmm. This is fine. 2 has to be one of these. We only have the 2 defined here. We don't have really a 2 defined here. Oh, this has to be the same set. So if this is 2, that forces this to be 0. Therefore, this is either 0, 1 or 0, 4, and this would be 1. That seems fine. Oh, this 1 eliminates 1 here. Okay, so this is 7, this is 2. That makes this a 1. The 7 must be 20-something, and then it must be 26 specifically, because it must be even here, and it has to be different modularity, right? So 2 mod 3, 0, 1 mod 3 means this is 0 mod 3, and it has to be even. This is 2, which forces this to be 0. This is also 0, so this is 1 or 4 here. This is 5 through 8 again. The remaining digits here are what? Okay, this 2 eliminates 2 here. So this is 15 to 18, so this cannot be the smallest. This is 5 or 6, so this must be smaller than this digit. Remaining digits in box 7 are what? 3, 6, 3, 4, 6, 9. The 7's 26. This is 1 or 4 here. 1 cannot be here. The remaining digits here are what? 1, 2, 5, and 9. And 1 cannot be here. Okay. Okay, so this is the smallest 1, 2, and 7. Okay, this is 26, so this cannot be 26 here. This can't be 26 here. This is not 0 mod 3 here. So that's interesting. This is the largest 5 here. Second largest. Third largest. So this cannot... It could be 9. This can't be 4 because of the 4 here. Where the... So the 17th largest, the smallest 5 has to be one of these two. Interesting. Okay. No, we don't have anything there. What are the remaining digits here? Could be 1, 3, no 2, no 4, 5, no 6, 7, 8. So those are the possibilities. What about here? Cannot be 1, could be 2, 3, 4, no 5, 6, 7. Okay. And then these, unfortunately, well, these can be 3, 4, 5, 7, 8, 9, but 4 obviously cannot be any of these. 4 can't be here. 9 can't be either of these. 6 obviously can't be either of these. These can be 1, 2, 3, 7, 8. No, 1, 2, 3, 6, 7, 8. And this can't be 6 here. This can't be 2 here. This can't be 7 here. Okay. Interesting. So this is only 2 through 7. This can never be 9 because it's smaller than this one. So because of that, we know where is the 9 in box 1. It must be one of these two digits, which means this can never be 9. So one of these is a 9 here. One of these is a 9. Right, because this digit must be smaller than this. So it still could be 6, 1, but this is at most 6, 8. It can never be 6, 9. So if there was a 9 here, that would break that. Where's the other 6s? We don't know. Oh, if this is 6, this would have to be 20. This would be the same modulo. So 6 is 21 through 24. The only modulo there would be 23, and it's not possible. So this cannot be 6. This is a 1, 2, 1, 2 pair, which forces this to be 6 here. So this is 20 something, and it cannot be. It's 21 through 24. So this is 2, no 2, 5, 7, 8. This is 1 or 4. So this is 1 modulo 3 because it cannot be 23. Well, it couldn't be 3. It can't be 0 mod 3 here. And why can't it be 2? It should still be able to be 2. It can be 2. So, okay. No 1, actually. This is 2 or 4 then. 21, 23 is here. This has to be 22 or 24. So that actually works for both of these and this one. Okay, so that's not helpful. This is 6. Therefore, this is 1 or 2, and it has to be 0 here, right? Because it cannot be this. 1 or 2 must start with this. It must be rank 0 something. If it's 1, it could be 1 or 4, right? Because if this is 1, it must be the same modulo. It's 1 or 4, and that works either way. So this is if this is 2, it could only be 5 or 8, and that works. All the ones. Okay, so this, well, the 1 doesn't have to be here. So, okay. That's 1 or 4. This is 1, 2, 3, or 4. The other one we don't know. Okay. Ah, this is not 0 mod 3 because it's no 6, right? 27 has 25. Anything that starts with 7 in 9-digit numbers, 25 to 28. And we already have 26 here from the way that this clue is set up. This is not 0 mod 3. Neither is this. That's not 0 mod 3. Therefore, 0 mod 3 must be here. So this is 3 or 9. Okay, that's interesting. These are different ones. Yeah, coloring doesn't really help, I don't think. I don't know. I'm just going to clear the coloring. 20. Okay, so this is 18. If this is 9, that would be greater than this digit. So this cannot be 9. So we know where the 9 is. Okay, so this is a 3, 6, 3, 6 pair, which eliminates 3 and 6 in the rest of the box. Therefore, this must be 9 here. And the reason why this can't be 9 is this is smaller than this digit. And this can go only up to 5, 7. So this 9 can never be here. This is 794 here. And this is the 26th largest one, which means the other 7s require a 9 next to it that are larger than it. So 9 cannot be here. Where is the 9 possible in box 9? It can only be here. So this is 7, 9 also. That's interesting. This can never be 7, 9. But it could be 25 here. Okay. It's likely this is 7, 9, and this is 28 or 27, and this is 27 or 28, but we don't know. This is 14th. This is larger than 14, so it must be one of these. If this is 15 or 16, I guess this could be 2. This could be 6, and this could be 1 here. That's possible still. Unlikely, but possible. These cannot be 14. So, because we have a 14 here. So this is 5 or 7. So this digit must be greater than this one. So it cannot be 2 or 3. It's 4, 6, or 7 here. This 5 eliminates 5. Okay, well, I don't even know why. Yeah, I should have gotten that in the start. This is not, sorry, this is not 2. This is a 5, 9 pair here. This is 6, 1 or 6, 2 here. That's fine. This is 23. This can never be, well, this could be 24 though. This is a 1, 2 pair, which eliminates 1 and 2 in the rest of the column, so this can't be 2. This has to be, what are the possibilities? 2, 3, and 6, and 8. Okay. Oh, this is a 3-6-3-6 pair, which eliminates 3 and 6 in the rest of the row. So this can't be 3 or 6. This is 1. This can't be 3 or 1. So it's a 5-7-8 triplet, which means this is 1, 2, and 3. Okay. Hmm. Okay, so let's look at ones. We don't have very much information there. Twos, things that start with 2. 2, 3, 6. This is 2, 1. So this is always going to be lower than this one. So this cannot be 5, and this cannot be 8, but that doesn't really tell us much. 2, we don't know about these. We don't know about these. This can't be 1. And this can't be 1 here. Okay. This is the largest 5-digit. So it could be 6, 7, and 8. That would be fine. This has to be the smallest one. That's fine too. 3s are done. 4s. This is 4, 1, and it's the 14th. This still could be 4, 1 here. This can no longer be 4, 1, and it would be the 15th anyways, if that were the case. This still could be 4, 1, and it's the 13th. Because 4, 1, whatever number that is less than 4, 1, 9 here. This 7 means that two other sets, since this is 26. Oh, this is 7, 9 also, and this is larger. Right? 6 and 8 is going to be larger than 4. So this has to be 27 or 28 here. This, if it's 7, could be smaller. It could be 25. That does actually work. Oh, it doesn't. This can never be 7. If this is 7, again, it would have to be 25 because it can never be 7, 9 as a number starting out because the 9's already in the box. So it's not greater than these, so it would have to be 25. But the 2 and the 5 would be in the same set, so this can never be 7. So 7 does have to be one of these 3 digits here. 25 cannot be either of these. This could be, oh, this can't be 7 and 9. So this couldn't be 25. Where is the 25 possible then? It has to be here, right? 25 cannot, sorry, that's not right. No, 25 could be here. So if 7's here, it cannot be 25. If 7's here, it has to be 25. Okay. If this is 795, that would be larger than 794, so this would be 7, and this would have to be 8. So I don't think this can ever be 8. If we try to make this the 28th one, which is the largest 7 starting 9-digit number, 795 is never going to be larger than 796. So this can never be 28. That doesn't tell us anything. Okay. Nine, 3, or 7. Ah. If this is 33, the smallest would be 9.5. If this is 33, the smallest is 9.3. Either way, you can never have a 9.1 here because that would be smaller than either of the 33 possibilities, right? So this can never be 1. This has to be 6 or 8, which is always greater than 45. So 9, 6, and 8 is always greater than 9, 4, or 5. Therefore, this is larger. This is therefore 5. This must be then 7, which makes this 34. If this is 17, this has to have a 5 here because that's in this 5 set. This is the 4 set. This 4 means this is a 1 mod 3, which means this can't be 4. This is 22. Because we can't have 21, 23, and the 24 got eliminated here. So this is 22. This is 24, so this cannot be 7 here. This is 34 because it's 9.5. This is 35, so this has to be at least 9.6. 951 still is less than 9454, so this actually still works that way. This is less than this, which is less than that. That's already less than both of them, so that's fine. The other 6 is a 24, so it must be greater than... It has to be at least 5 or greater. This is 4. So, yeah, that works. 6 goes with 2 and 4. That's 0, 1, 2 mod 3, 1 mod 3, 0 mod 3. 8 goes with 0 or 3. Actually, can't be go with 0. So 8 goes with 3. And it would have to be 30 or 32. The 6, so if it were 6, it's 24. If it's 8, this has to be 30 or 32. We're not sure which. This is interesting. 1, 2, and 8. Or if this is 1, so it could match, this could be 13, or this could be 13. We're not sure which, right? It could even be 1, 9, and this is still 13. This 4, though, is 15 or 16. We know that for certain. What about this? Don't know. 7's one of these 3. 8. Okay, so 8 would have to be with 30-something. And the problem with that is that we already have 31 here, and that leaves only 30 and 32 as the possibilities, and this must be odd. So this cannot be 8 here. This is 1 or 2. We have 1, 2, 1, 2 pair, which eliminates 1 and 2 in the rest of the row. So this can't be 1 or 2. This is 3, 8. So the 1 or 2 is with 0. So this has to be 0 because it cannot be the 1. Any 1 or 2 starts with a 0 or is a rank 0 something. Cannot. Okay, so 0, 1. It would have to be 2 if that were the case, and that can't be 2. Right? Because it's as odd. So it can't be 0, 1, 0. Sorry, 0, 1, 1, because those are the same set. 0 and 4 doesn't work, obviously, because it's not odd. 0, 3 is the same set, so this cannot be 1. This has to be 2, which makes this, it cannot be 0, 5. It has to be 0, 7 here. So this is 0, 7. This then has to be 4 and 1. And 4, 1, 3, or 8 is less than 4, 1, 9, which forces this to be 13 in rank. This cannot be 13 in rank. It actually has to be 15 in the rank, because this is not 1. So this is 2, this is 1. And 4, 2 is greater than 4, 1, and 4, 1, 9. This has to be 16th in rank. because it's 5 or 8 here. So this cannot be... This has to be less than these two. So it has to be less than... It has to be at least, at most, a 6 here. So this can't be 7 or 8. This is 3 or 6. This is 2. This is 07. So this cannot be... Wait, no, it's this one. This can't be 07. Because, yeah, this must be less. 2, 1. This must be less than that, too. So this can't be 07. Where's the other 2? So where's the only 08 possible? It has to be here. Actually, it could be here. Okay, never mind. If this is 2, I guess it could be 1, 9. So 2 cannot be here. This can't be 0 then. 6 can only be with 2. 7 and 8 can also only be with 2. 8 can be with 3 though also. Okay, so if it's 6 and 2, these are different sets, right? 6 and 2, this can't be 1 here. 7 can be with 2. Okay, so 6, 2, that's 0 mod 3, 2 mod 3. You need a 1 mod 3, that's even. So that would only be 4. So that's possible. 6 could be 24. We have a 21. We have to specifically be 24. So, yeah. That's fine. So any of those could be 24 with the 6. 7 would be with 2 and another even. We have 1 mod 3, 0 mod 3. 7 could be with... We already have 26 though. So I don't think 7 can be either of those. Right? The only, 0. 0, 3, 6, 9 are the only 0 mod 3s, and the only even ones are 0 and 6, and 7 doesn't belong in the 20th rank. So it would have to be 26. So 7 cannot be either of these. Since 7 cannot be either of these, where is the 7 in column 9? It has to be here. So this is 7, which makes this 20-something. 25, 27, or 28, I believe, right? Yeah. This is 5 or 7. This is 5, 7, or 8. Oh, can't. Okay, so this cannot be 7, 9. So it's less than this. It can't be 8 then. So this is 25 or 27. 1, where's the 1 in column 9? It has to be here, which forces this to be 0. And this is an even digit. So it cannot be... It has to be 2 mod 3. That only leaves 2. So this is 0, 2. This cannot be 2 then. This cannot be... This is 1 or 4. This is 1, 3, or 4. This could be 0, 3 or 0, 1, 4. Either way, this is 0, 2 then. This could be 0, 2, 4, right? Actually, hold up. So if it's 6, this is 2 and 4. If it's 8, it has to be... it can't be 30, and it can't be 32. And 31's taken, and 29 is taken. So this doesn't work. So this must be 6. This is not 3. This is 6. This is 2, and that's 4. Because that's the only 6 remaining that we have. Right? We have 23, 21, and 22 already. So this must be 24. Which makes this 8. This has to be 3. So that's 2 mod 3, 0 mod 3, 1 mod 3. And this is 30 or 32. We're not sure which. Actually, no. This is smaller than this. So this must be 30. This must be 32 then. And it has to be larger than 8.5. So this must be 6. Right? 861 is greater than 851. Yep. So this can't be 8. This can't be 8. Okay. These can't be 8, so this must be a 3, which makes this a 7. So we have 273 is 07. 21 and 2. This cannot be larger than 27 because it's 23 or 26, so this must be 06 then. It's larger than 21 though, so this is 05. We have an 08 left here, and this cannot be 08, so this must be 08, which makes this a 2. This is 1. This is 2 mod 3, which makes this not 5, because 5 is 2 mod 3, so this is 7. This is 1. This cannot be 06, because the rank has to be 1 through 4, so this is 03, which means this can't be 03. This is 01 or 04. This is 01 or 04. We don't know which. That means this can't be 1 here. This can't be 2 here. We don't have anything else there. This 2 must be larger than all the other 2, so it must be larger than... It must be at least 7 here, so this can't be 3 or 5. This is 27th, which is smaller than the largest 7. This can't be 7, so this must be 8. But it is already either way, 7, 9. Okay, so it does have to be greater than another 7, 9. Yes, this is 7, 9, 4. So this must be 7 and 9, which makes that 5. So 5 and 3 and 7 cannot be here. 9 eliminates 9 here, so that's 7. And it eliminates 9 here, so that's 3. This can't be 3 or 7, so this is 5. And now we should just be able to figure it out just by ranks, right? This is 2, 7 with 8 or 9. And it's the largest 2. Okay, so let's look at, maybe start with 1s. That's not going to help. One of them's 1, one of them's 4. Where's the... This is 3. What about the O2? We don't have any information there. This 6 eliminates 6 here, so this is 8, this is 6. That leaves the remaining digits in column 7 to be 2, 5, and 8. And the remaining digits in column 8 to be 3, 4, and 9. Well, this 0, 3 has to be 1, 3 at most. So therefore, this is 1, 3 here. And 2, 5, 8 can still be smaller. This, one of these is 1, 3. We're not sure which. 1, 3, 4 could still be smaller. We don't know. Okay, so that's not helpful. What about the 2s? This is the 5th, so it's the smallest 2, 2, 1, 8. We need to look at the 6th one. Where is, this is 6, so it could be 2, 3, 6 or 2, 6, 3. The 7th largest one is 2, 7. So either way, it's going to be smaller here. And then this is the 8th, which is 2, 7, 8, or 9, which is larger than 2, 7, 3. So that works. 3s are all done. 4s. We have 13, 4, 1, 3, which is smaller than 4, 1, 9, which is the 14th, which is smaller than 4, 2, 9, which is 15, which is smaller than 4, 5, or 8. So that works. 5s, starting from 17, 5, 6, 7. So this must be bigger than that. So it's 5, 6, 9, which makes that 3. So this is 6 and 3, which means this can't be 6 and this can't be 3. This is 1, 3, 4. I think that's similar to the other 1, 3. There's another 1, 3, 4 here too. Yeah, well, 1, 3, possible 4. Okay, so this is 5, 6, 9. Okay, so that's helpful. That means this 2, we have 2, 1, 8. 2, 6, 3 is bigger. Actually, we already know the 7's larger. 2, 7, 3. Okay, so that's fine. 5, 6, 9 is greater than 5, 6, 7. We have 19. So this must be greater than 5, 6. So this is 5, 7, which means these can't be 7 here. This is 3 or 4. This is 3 or 4. 5, 7 something is going to be larger than 5, 6, 9. And it's going to be smaller than, where's the 20? 5, 8, 6. So that's good. So we've got all the 5s done. 6s. This is the smallest, 615, followed by 65 something. 23 is here. And 65, if it's 652, that would be smaller than 654 at minimum. So this cannot be 5. This has to be 7 or 8. 24 is here, and therefore it has to be greater than 3 and 4. Therefore, this is 9. This is 4. 6, 9 something is greater than 6, 8 at most something. So that works. So 6s are done. Now we have 7s, which looks, we need 25. We have 28. We have 26, 28, and 27. So this must be 25. And it does work. 7, 4 is less than 7, 9, 4, which is less than 7, 9, 5, which is less than 7, 9, 6. So that works for 7s. 8s. 29th is 8, 2, 1. 30th is 8, 2, 7. 31st is 8, 5, 1. And 32nd is 8, 6, 1. So that all works. And then we have 9s. 9... this is 9, 3, or 4, which is always less than 9, 5. So this must be 33rd, and this must be 36th. So 9, 3, or 4. This can't be 4 because of the 4 here. So this is 3, this is 4. 9, 3 is less than 9, 5, 4, which is less than 9, 8, 2. So this has to be 9, 8 something, which makes this not 8. This is 5, this is 7. So this cannot be 1 here because of this is at least 9, 8, 2. So we have a 2, 3, 2, 3 pair, which eliminates 2 and 3 in the rest of row 7. So this can't be 3. This is 1. This can't be 3 because of that 3. So this is 2. This is 3. So this is 9, 8, 3. 9, 8, 3 will be greater than 9, 8, 2 no matter what. So that's fine. Okay. This is 1, 4. So this is larger than 1, 3, 4. So this is the 4 and this is the 01. Okay. So now we need to look at the 1 starters. This has to be 1, 3, and, well, it could be 8 or 9. This is the smallest one, so it's 1, 3, 4. 1, 3, 8, and 9 is always going to be less than 1, 4, so that's fine. 02. 02 is here. 1, 3. It cannot be 4, so it has to be at least 5. Sorry, it has to be greater than 4, so it has to be at least... this 5 eliminates 5 here, so this is 8. This can't be 8 here. This can't be 8 here. This is the second largest, so this eliminates 4 here, because this has to be greater. So it must be at least 1, 3, 8. That means leaves an 8, 9, 8, 9 pair in row 3, which eliminates 8 and 9 in the rest of the row. So this is 6, 5, 4. This 8 eliminates 8 here. This set has one of every set. How many modulos do we have? This is 2 modulo 3, 2 modulo 3. So we have two 2 modulo 3s with a third modulo 3 being here and must be 2. This cannot be 2, so this is 6, which means this can't be 6, cannot be 6, and this can't be 6. These are both 2 modulo 3s here. We have a 4 and a 9, 3 and a 9, and a 4 and a 7. So that leaves this as 1, 2, 5, 8, or 6. 1 cannot be either of these. Where's the 1 in row 6? It has to be here, so that's 1. We need a 6 then, and 6 cannot be here. So where is the 6? It has to be here. That leaves this as 2, so this can't be 2 here. We have to have, what, 2, 4, and 9 remaining. This can't be 4 or 9, so this must be 2, which means neither of these are 2. This 4 here eliminates 4 here, so this is 9 and 4. This 9 eliminates 9 here, so it's 8 and 9. Do any of the ranks matter anymore? I don't think so. 9, 3 is always less than 9, 5, so that doesn't matter here. 1, 4 is always greater than 1, 3, 9. 6, 9 is always greater than, where's 23rd rank? Here, 6, 7. And 7, 4 is always less than 26th rank, which is 7, 9, 4 here. Yeah. So these ranks don't matter, so now it's just disambiguating these. So what is this digit? This digit is a 3. This could be 5 or 8, but it cannot be an 8 because it's an odd digit. So that's 5, which makes this 2, which makes that 8, which makes that 2, which makes that 5. So this is 8, and this must be a 7. Woo! Yeah, I don't know if I would consider this very hard. It just takes a while. That's the only thing about this. It just takes a while, right? You just have to logic through everything, and there's a lot of the logic through it. But it's not complex logic either. So I don't know if I would consider this very hard. It takes a while to do. It's a very long puzzle, but it's not very hard. I would consider this hard. And even then, like, the logic behind it isn't hard. It just takes a while to go through all the possibilities, right? So anyways, I hope you enjoyed this long solve. It's a very long solve. And I'll see you next time on Frank Puzzles. Take care.